Now let's consider the case where the instrument that we use, the invitation, only acts as a nudge to increase the probability of treatment. So now we're going to assume that there are no never takers and there are no always takers. So in a sense there are only compliers, but the compliers now are slightly different from the compliers that we had before. So we have two types. Some of these compliers were invited and some of them were not invited. We assume that if you're invited, we assume that 30% get an explicit invitation for the training session and 70% is not explicitly invited for the training session. Now the probability that people go to the training or actually exert effort at the training is 60% for people that were explicitly invited, and it's only 20% for people that were not explicitly invited. Yeah, so these people might either not turn up at the training, or if they're there, they may not really exert full effort. And therefore the probability of actually getting trained, learning the skill or whatever the training is about is lower for the people that are not invited than for the people that are invited. Yeah, otherwise it's the same as above. So the expected earnings, if you're not trained, are going to be 1. And the expected extra earnings, if you get the training, is going to be 3. Yeah, so the expected earnings will be drawn from a normal distribution with expectation 4 if you get the training. Yeah, so type here just refer to whether you got the explicit invitation or whether you didn't get the explicit invitation. So as above, we're going to keep track of earnings without receiving the invitation. We're going to keep track of the training effect, the total earnings effect, and who was trained and who was not trained. So we're going to create a data frame, and we have a function which is very similar to the one we had above. So above we had the function data simulation. Now we have data simulation with probability of treatment. And again, we define some default values for the parameters. So beta is now simply a scalar. It's no longer a dictionary. Tau is also a scalar. But n is still a dictionary, and we have two types, invited and not invited. So as above, we're going to loop over these types. Yeah, so generating the earnings without training is pretty straightforward. It's a normal distribution. Mu is equal to beta. The training effect is straightforward. So the mu for that is equal to tau. So we also assume this is normally distributed. So the difference now is that whether or not you get trained. So trained for people that are invited, so if the types are invited, is going to be drawn from a binomial distribution with the probability of training for people that are invited, and the probability of training for people that are invited is 0.6. Yeah, so the second time we go through this loop, we look at the people that are not invited, and the probability of training is then only 0.2. Yeah, so when we draw here from this binomial distribution, we draw with a far lower probability of success. It's 0.2 in this case instead of 0.6 in the case of people that were invited. Then earnings again are the earnings you earn without being trained, plus this factor trained, which is either 0 or 1 for an individual, times the training effect. So the additional earnings that the person will earn if they get training. So we generate the column for our data frame invited. We do this by gluing together the subcolumns that we have for invited and not invited. And we do the same for trained and earnings. So when we run this, we see that the first 5 rows of this data frame are given by these expressions over here. Now let's first make the simplifying assumption that we can actually observe whether somebody got training or not. Yeah, of course the point is going to be that we're not going to be able to observe that. But let's first look at a simple case where we can observe whether somebody was trained or not, so whether they invested the effort to fully understand the training and try to learn this new skill. So that's basically the difference between the mean of the earnings conditional on being trained. So that's the first part. So we get the data frame, probability. Then from this data frame, we select the people that actually got the training, and from these people I'm interested in their earnings. So we take the mean of that, and we subtract NP mean of df prop, and then now we select df prop dot training is equal to 0, and also here from these people what I'm interested in is their earnings, and that's what I take the mean over. And if I simply subtract these two conditional means, oh, I made a mistake. So what did I do wrong? Df data frame has no training. Oh, what did we call it in the data frame? It's trained, sorry, my mistake. So it's not training, it is trained, and I made the same mistake here. It should be trained. Okay, so if we take the difference in these conditional means, so the mean of earnings conditional being trained minus the mean of earnings conditional not being trained, we see that indeed we can identify the parameter tau, which is equal to 3. Yeah, so in our own data set we set this thing to 3, and with this estimator we can indeed recover this effect of 3, the additional expected earnings that you get if you do the training.